Hi and welcome back to Module 9. In this module we're going to talk about visualizing data and plotting the data in graphs and using different charts using the NumPy and Matplotlib libraries. So the first thing you do is that you have to import the Matplotlib library, and we do that as we always do. We import it as matplotlib.pyplot as PLT, and then you import the NumPy library as NP. First, we're creating some sample data for demonstration, so we can use this sample data in our charts after. So here x is equal to np linspace, and we've covered what linspace is in previous modules, so you can go back and look there if you don't know what it is. And y is equal to np of sine of x. So the first plot we're going to go through is the line plot. So this is a basic line plot. So as you can see here, the first thing we do is we call our the matplot library plt, and then .figure, and then the size of the figure we want to create. And then we plot in the x and y that we made in the previous code. And we create a label and call it sine curve. And then the color of the curve is blue, the style of the line, and then how wide it should be. And then we can also create a title for the plot. So we've called it basic line plot. And for the x label, we said x-axis, and y label, we said y-axis. So for to create the legend, you just type plt.legend, and we put in a grid and set it to true to make sure there's a grid in our plot, and then plt show to show the plot. And here you can see our line plot. So the next plot we're going to cover is the scatter plot. Here you go through the same things as you did before, but you say plt.scatter instead of plt.plot. So here it's exactly the same, and we've labeled it scatter plot. It's the same title, x label, y label as before, legend. If you want a grid, you set it as true, and then plt show. So let's run this. And here you can see the sine curve as a scatter plot. The next plot we're going to go over is bar charts. So here it's the same, but we create categories first. So there's different categories for each of the bars that we want to show. And here are the values for the categories. It's the same setup as before, but here you type in plt.bar. So let's run this code. And here you can see all the bar charts are coming up, showing the different values for the different categories. The last one we're going to cover for now is histograms. And here we've created that data as np.random.randn, and we selected a sample size of 1000. So here it's the same as before, but here you type in pld.hist, and let's run the code. And here you see a nice histogram. And what you can also see here is that we've put in edge colors as black, so it's easier to see the different bars.
Okay, so since we played a bit with the Matplotlib and visualizations, we can try to go a little bit advanced and try to build our customizable plot. So let's run the cell. This is the same workflow as we did previously. Firstly, we generate the function figure, where we create kind of the canvas for our figure where we're gonna put that. Then we call the function plot, where we choose the parameters and the customizable stuff for our plot. So here we put the label for the legend as a sine curve. Then we put the color of the lines as blue. We put the line style as kind of line. We can try to put the semicolon, so we're gonna have kind of the dashed line. Then we have the line width for the controlling of course the width of the line. Then we put the marker as how the points gonna show up in our case. Then we put the marker size as 4. We put the marker face color as a red, so in the inner part of the points they're gonna be in red color. Then we can choose the marker edge color as black, and so on. So you can look at the documentation of the matplotlib. It's not all the parameters for the plot, so you can play more. Then we can put the same function of title as the customized line plot, the names of the labels, and then we can also try to put, for example, the logarithmic scale, for example. So let's put x scale, and then to put in a log, we put the log, and we change the scale, and then we put the legend with the function, and then we put the grid on our plot to the value of true to show this. The next step in visualization, that's the subplots. So that's the kind of the big plot, the dash, where we put the multiple plots, the different types of plots. So it works in a way that we firstly create the big canvas where we're gonna put our plots with the same function, the figure. We put the figure size, and then step by step we define the different type of the subplots. So you can choose kind of almost any amount of plots you want to place. So it works in a way I generated here. So we have 4 plots, different types. So it works in a way that firstly you create the subplot with the function, you define it, then you put parameters as the number of rows and columns in a way, and then the index. So it means here in each subplot we have 2, 2. So it means that we have 2 columns and 2 rows in a way. And then the third parameter called the index. So we just put where it's going to be placed. So for example, the first one is going to be the first index. It's going to be placed in the upper left part, and then from the left to the right it goes, and then changing the row, it again starts from the left hand side. And then the same way we generate the plot function. We choose our variables that we're gonna plot, the color, and then the titles, and then we can plot the legend as well. The same here. So we define the row and columns, and then the index of our subplot. So it's has a second index. The same for the plot 3 and plot 4. And then we finally finalize the subplot with a tight layout to stick them together, and then finally show this as an output. And then at the next step we will try to show you how to use this visualization skills to play with the statistics. So we're gonna try to build the probability density function and the cumulative density functions. They are fundamental concepts for probabilities and statistics. And for defining the functions by itself, the PDF, it represents the probability of the variable taking a specific value or falling within a certain range is distributed across its entire range. One thing to mention, it's not the probability by itself, it's the probability of, or the likelihood of one specific value to fall in range of the distributed values. So it kind of the bins that we're gonna play with. And then another one, that's the CDF I mentioned previously. So that's the function that represents the cumulative probability of a random variable taken on a value less or than or equal to a given point. In other words, it shows the probability that the variable is less than or equal to a particular value. For those functions, we're gonna use the artificial data we're gonna generate with the NumPy. So here we're gonna generate the normal distributed data set. Those parameters means that for the first parameter 0, we choose as a median value for our data set, and then we put 1 as the standard deviation value, and then we want to have 1000 values in our data set. And then for creating a PDF plot, we're gonna use the same matplotlib library, the same step-by-step workflow. So we generate the figure with a figure size. Then we put the histogram. We apply our data set, the variable called random data. Then we choose the bins. So we're gonna have the 30 bins in our data set. And one thing to mention that regarding the normal distribution, we need to remember that around 60% of the values, they will lie around from 0 to 1, then around maybe 80% from -1 to 1, and then from -1 to -3, for example, it will be around 98% of all our values. And then we use the parameter density as a true to use the density probability. And then alpha, we use this parameter to put the transparency for our plot. And then the color and the edge color. Then we put the title, the labels for our axis, and then the axis by itself, the values. And then we're gonna put as well the customized PDF using the library SciPy stats, and then use the same way the data set we generated, but here we put the data. And then we put the histogram, the same way of putting the data, putting the bins, density, alpha, and then apply the X range for delineating specifically our X axis. And then once we run the code, it's going to take a while, we see those bins that we defined, 30 bins from -3 to 3, and then the customized, the same from -3 to 3. And then the 0, as we can see, normally that's the median value, and then on the edges we have the less distribution than we have. And then those the probability density values that show us the kind of likelihood of each value falling in range of the each bin, for example. The next step we're gonna do is the cumulative distribution function. So as I mentioned previously, we're gonna show the cumulative likelihood of value to fall within this range or the less value than can have. So the same way we choose the histogram, the random data, bins, density, but then for the cumulative distribution we use the additional parameter called the cumulative, so we put it to the value of true, and then the same parameters for transparency, color, etc. And then for the customized we put the as well the line, as you can see here we run the code, so the red line. So we put the line style here, the parameter, so it works in the same way as we showed you previously at the beginning of our lesson. So for the cumulative distribution function, we can see how those values gonna distribute in terms of the cumulative probability. So for example, for the value of 0 or even less, we have around 60% that this value will fall. And then as an example for the kind of real world application, we're gonna plot the temperature change over a period of time. So we are using the open source, as you can see here from the website. We downloaded that CSV file, but you can try also to put it in a link as well in your variable. So as previously we did, we are importing the pandas, the matplotlib library, put in a variable over the data set, and then to be more consistent, we put each column to each variable. So we choose the column year from our data set called data variable, and then put it to the variable of years. The same goes for anomaly. And then we put our line plot code. So firstly we generate the figure, then we call the function called the plot for the line plot. We put the marker, we put the line style, how the line gonna show, and then the color, and then as well the titles and the labels. So once I run the code, you can see those markers that we put is corresponding to O, and then the line style. For the line style, just for showing, we can use, for example, the semicolon to change it to kind of the scatter plot, so-called, so have the pointed data. So try to play with that and take a look at the documentation of those libraries. Good luck.